Dinosaurs were curiosities to see in museums or movie monsters that haunted our nightmares or objects of childhood fascination. Pretty much irrelevant to us today and unworthy of any serious study. But these stereotypes are absurdly wrong. They've been dismantled over the past few decades as a new generation has collected dinosaur fossils at an unprecedented rate. Somewhere around the world, from the deserts of Argentina to the frozen wastelands of Alaska. A new species of dinosaur is currently being found, on average, once a week. Let that sink in, a new dinosaur every single week. Steve Bruzat.
Hunting tyrannosaurs. We live in a golden age of fossil discovery of all kinds, and this includes many new dinosaur species. Conventional creationists ought to be worried by the existence of dinosaurs, in spite of very shallow attempts to rewrite Genesis to include them. The problem is, their existence is absurd, under any model that includes only the flood and a mere 1,000 years of in-universe time. Some were vastly overbuilt killers, but they grew that way to prey on even larger herbivores. They could not have been made that way, as part of a holy creation, but they make sense in a world where death rules over nature. All those teeth, spikes, and armor met a real need because of the laws of sin and death. However, none of these creatures is mentioned by the Bible. Except perhaps for Job's behemoth, but this is likely to be a modern creature that Job would have known, such as a hippo. There are also some references to mighty sea beasts which are certainly whales. Like the Leviathan, Job's behemoth represents a spiritual power, or symbol, rather than any real beast. It is more authentic and truthful to accept the intended meaning and archaeological context of the Bible than try to invent biblical dinosaurs. There are far too many of them to share any one era. There are over 1,100 identified species and 300 genera. Instead of cluttering up the planet all at once, these species were part of many different and changing ecosystems, coming one after another, each with a top predator or two, a particular balance of prey species, plants and surrounding geography and climate. Paleontologists document the details of many of these ecosystems, demonstrating that they were separate eras. Microfossils assist scientists to do this. They are fossils so small, they have to be reassembled under a microscope, with hip and jaw bones, sometimes as small as an eyelash. Microfossils come from lizards, frogs, and other tiny creatures, leaving bones, teeth, and even fossilized poo, which shows the shape of creatures' guts and the content of their food. They come from widespread and numerous creatures, so there are many examples. Along with plant remains, from seeds and pollen, and tiny shells in the oceans, researchers can trace long-term changes in ecosystems, understanding their plants, landscapes, and the food chain supporting larger creatures. Every part of the puzzle brings back to life, one significant time or another, in nature's life story. It is the goal of paleontologists to try to piece this whole complex history together. Their study has revealed historic shifts in every aspect of life on Earth. In some of Earth's ages, it was totally different from today, with a single continent stretching from the North to the South Pole, and an unbroken ocean with no frozen ice caps. In the most remote eras, its atmosphere has been non-existent, or toxic, without the oxygen needed for humans or any large animal to live. Riding a wave of new life. Each ecosystem discovered has surprises. Even islands like Japan had their own land-based dinosaurs, such as Carmoisaurus japonicus. What is clear from all the recent fossil discoveries is that the rise of the dinosaurs was a matter of chance. They were towards the bottom of the pile for quite some time, especially in drier areas. They were the prey of giant crocodiles and their many relatives, reptiles that were larger and fiercer than they were. However, the Earth changed, the single vast landscape of Pangaea, splintered into individual continents during its geologic cycles. That created a disaster for life as a whole, with many species killed, but with death came opportunity. Dinosaur adaptability won them a secure place in many new ecosystems. In those early years of the Jurassic, their numbers exploded as they moved out into a newly emptied world. They then split into many different species, the ancestors of the famous families of dinosaurs that we all know. Paleontologists can trace the development of whole families of dinosaurs. For example, we now understand that the earliest Cretaceous tyrannosaurs were relatively small. However, they had distinctive adaptations that promised greatness in their descendants. Ancestors of the famous T-Rex include Moros intrepidus. This creature hunted in the shadow of older lineages, such as allosaurs, who were at that time the top predators in North America. We have all heard of the awesome Tyrannosaurus rex, but no Asian, Australian, European, or South American dinosaurs lived in fear of them. They would never have seen one. The many families of dinosaurs were spread across vaster periods and more diverse ecosystems than we can imagine. The photo is of a Tyrannosaurus rex, called Sue, a fossil discovered in 1990. She is in her own way beautiful, as one of the largest, best preserved, and most complete of her species ever to be discovered. She did, however, have a painful life, sustaining a number of healed injuries including broken ribs from struggles with her prey, infections, torn tendons, and arthritis. The other dinosaur found with her, the even heavier Scotty, had broken ribs, an infected jaw, and bite marks on his tail bones, probably caused by a rival of his own species. Their adaptations came with significant costs, including a shortening and shrinking of their front limbs. Their hands were cut back from the usual 5 to only 2 digits with limited function. The forearms were reduced to small non-functional structures. This was likely because they were a burden to adults and adolescents during competitive feeding on the bodies of their prey. The bodies of the largest prey were a feast that could feed a pack for days. Longer arms could have easily been bitten, amputated, or infected, resulting in weakening, sickness, or in extreme cases death. Baby tyrannosaurs needed to grow quickly. To survive against rivals and hunt successfully, they put on 2 kilograms of weight a day from hatching. It took a lot of food to grow those massive bones and teeth. They were probably opportunistic feeders, hunting but also feeding on dead animals as chance permitted. Adolescents would not have followed larger herds, but targeted babies and the young of any species. Adults would have been able to inflict a lot of damage. Analysis of their fossil poo shows that they were not picky eaters. It contains a high proportion of bone from other dinosaurs, but also bone from small mammals. They developed the body parts required to crush bone and armor and consume other creatures whole. Conflict and suffering were as expected in the dinosaur era as in ours. Indeed, diseases such as cancer are visible in early fossils. That shows how decay and suffering have not changed since the origin of life on this planet. Endless ecosystems. Not only were dinosaurs spread out in time, but also across continents. Abelisaurs ruled the food chain in North Africa and elsewhere during the period when Tyrannosaurus rex was king in North America. Members of the abelisaurid family were between 5 and 9 meters long from stubby snout to tail tip. They had powerful hind limbs and extensive decoration of their skulls with grooves and pits. One of these dinosaurs, Carnotaurus, had tiny forelimbs like T-Rex, a shortened bulldog-like head, and bone crests to protect the eyes from attack. Recent fossils from Morocco show that at least 3 species of this family lived together 66 million years ago, sharing the role of top predator. That they were coexisting demonstrates that predatory dinosaurs and their food must have been abundant in North Africa, right before the mass extinction. North African dinosaurs came in many sizes and feeding specializations and were successful until that event. Australia has its own dinosaur fossils, including what are probably the first megaraptors, with monstrous claw-tipped front limbs. These creatures lived during the Cretaceous and are found at the Winton fossil site. The photo is one of their pointy front limbs. However, the dinosaurs never conquered the oceans or the skies, even at their greatest expansion. The seas remained the home of reptile species, including plesiosaurs, ichthyosaurs, and gigantic sharks. While reptilian pterosaurs, like Dimorphodon, and many others flew short distances. Quetzalcoatlus became the king of long-distance flying, able to circle for hours in search of prey. One current area of research focuses on recreating preserved and altered proteins to determine how fossilized animals functioned. Were they, for example, warm-blooded? Initial investigations even confirm known relationships between fossil species based on their use of proteins. As Buckminster Fuller put it, you never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete. What creationists have tried in the past is to compress natural history to fit the timing of Genesis. This is out of respect for God's word, and I admire that motivation. Yet because their attempts are materialistic, working within the strict limits of natural, scientific evidence and with rocks and fossils to explain events like the flood, they could not succeed. Seventh-day Adventists are involved in dinosaur research with teams from the biology department of Southwest Adventist University. They are led by Professors Art Chadwick and Jared Wood, excavating dinosaur bones from the Upper Cretaceous, Hell Creek and Lance deposits. These are some of the richest fossil beds in North America. Dr. Chadwick, for example, has a particular interest in dinosaur taphonomy. That is, studying everything that happens to an organism's body after it dies, including which parts become fossilized. These excavations provide detailed information about the animals, their diet, and the greater ecosystem of which they were a part. The university has an extensive fossil collection, which is open to the public. However, as some Christian institutions do, they present scientific information and traditional biblical explanations together without attempting to resolve their contradictions. Students and church members are left to decide how they relate for themselves. Current discoveries uncover not just the overall development of species, but regional changes during particular eras. The idea that gaps between fossils are a problem for paleontologists is untrue. Each new index fossil adds fine details to our picture of life, covering periods in more detail than ever before. With each discovery, the idea that so many species from different eras, including top predators, live together as most flood models require, becomes harder to believe. Life will find a way. This 2-meter-tall raptor dinosaur died protecting her eggs. Her nurturing was retained in distant relatives like birds, which conquered environments that dinosaurs never exploited. Flood-based creationism combines all these species and all intermediate forms, and they somehow function as part of the same oversized ecosystem. It requires that they all began as humble plant eaters and were altered by unknown means into the fierce predators and prey animals, whose remains we discover today during a short period. There's nothing in the Bible about alterations as complex as that. Accepting great age or long-term adaptation is seen by conservatives as a flaw in personal faith, to the point that some Christians use the terms evolution and atheism interchangeably. However, evolution is only one component of scientific theories and fits pretty well within some forms of creation. Deep time or genetic pressures do not limit God's role. Dinosaur descendants and others. The remains of once living creatures witness that nature has passed through many eras of biological life. Consider a few examples. The first is the hyenodonts, a family of large mammalian predators. Some grew to a size not seen in living creatures since the dinosaurs died. They were the size and shape of a miniature rhinoceros and weighed up to 1,100 kilograms. They thrived as top predators for millions of years over northern Africa and Europe, going extinct 15 million years ago as a result of environmental change. Dinosaur descendants, the phorusrhacids, or terror birds, were gigantic flightless birds. They dominated ecosystems across South America and beyond. They earned the nickname thanks to strong skulls and beaks, muscular necks, long sickle-shaped talons, and they were up to 3 meters tall. Like the raptor dinosaurs, they were successful. Their family thrived for 53 million years until less than 1 million years ago. Individual species didn't survive that long, but this was a respectable run. In New Zealand and Australia, the moa and thunderbirds like Genyornis newtoni also became gigantic, just like their ancestors. The Creator has made biology chaotic, yet recurring. It is pushed into fresh forms by genetics and competition. At the same time, life is like jazz music, which continuously riffs on shared melodies. Long before a saber-toothed cat or a dinosaur existed, the animals seen here were fossils deep in the rocks. They were the last of a once dominant family of meat-eating animals known as gorgonopsids. About the size of a tiger, but with skin somewhat like a rhino, they looked reptilian but had some adaptations more like mammals. Also some that were unusual, including that grooved tooth pouch in the lower jaw. The specific species seen in these examples was like the Cretaceous dinosaurs, among the largest and last of their family. Well, not quite the final members, as a few gorgonopsids survived the early Triassic period's mass extinction, only to dwindle, becoming smaller and fewer, until they finally disappeared forever. This once successful family, with its many varieties, did not disappear without preserving something good. Some of their distant, much smaller, and hairier relatives shared their genes. Those creatures would live on, to dodge carefully, between the feet of dinosaurs, in the next of Earth's great ages. The dinosaurs' long reign was known for its fierce combatants, towards the end. It was almost like an ecosystem full of ninjas, especially raptor dinosaurs, such as Daleosaurus, Graciliraptor, and Cynovenator. Although sometimes, mammals bit dinosaurs back. A recently discovered fossil is described in the science journal Nature. It prompted a headline, like a punchline from the Ice Age movie, Early Mammal Bites Dinosaur, Combatants Buried by Volcano. It is a dramatic fossil, with two intertwined skeletons. One is a small but fierce mammal, with its teeth and claws locked into the body of a beaked dinosaur, 3 times its size, in a way that suggests attack, not feeding on its dead body. The eruption that caught both animals mid-fight has preserved them in stunning detail. The primitive mammal's paw digs into the dinosaur's lower jaw, while the other one grips a hind leg. At the same time, its lower jaw is biting into the dinosaur's rib cage, as seen in the photo. This encounter, a smaller mammal attacking a larger dinosaur, was probably not typical. Usually, it was the dinosaurs that devoured the mammals. For every top predator, known from famous fossils, there were hundreds of lesser creatures fighting to get their next meal. It's easy to think of many other examples that were all part of eras of life, with radically different conditions. Just how many entirely separate ecosystems are traditional creationists willing to ignore? It's no wonder teens find this form of creationism confusing, especially once they leave church-run schools and see the quality of the evidence that was hidden from them. How many educated people have drifted away from Christianity because it takes too narrow a view of our shared history? God's ancient enemy. As David Bentley Hart writes, death is God's ancient enemy, and its final defeat will show that its entire existence was flawed. The problem of evil is that in this universe, it seems to rule. Something will come along sooner or later to take you down or even eat you. Life's many eras of conflict demonstrate this. If cancer doesn't kill, a heart attack will. If you avoid all the usual suspects, your stem cells will run out or you'll die accidentally. Even the stars are going to burn out in time. This state is alien to God's nature and intentions. Until now, creationism has been unable to explain why decay and death affects every living thing. After all, only humans sinned, so how did the rest of creation, including other planets and galaxies, become affected by our punishment? Understanding the curse of entropy gives us a universe-wide explanation. Decay and death are flaws, growing from this universe's laws. They are not only central to biology, but damage all of nature. It will not be good or holy, reflecting the Creator's love, until both are gone forever.
Impact. Understanding how we decipher a great historical event, written in the Book of Rocks, may be as interesting as the event itself. Walter Alvarez.
As Christians, we look for the end of suffering and the coming of a new heaven and a remade earth. Compared with that paradise, our world seems quite broken. It's possible that sin just affects Earth, yet evidence suggests that other worlds follow the same rules as our own. Consider how bleak and wounded Mars is, given that it once had shallow oceans, seasons, and a substantial atmosphere. The photo is Terabia Terra, a vast Martian plain, about 4,500 kilometers across, marked with many layers of craters. One day, humans will live on Mars. This is the landscape, an atmosphere their landing craft will see from space. The large crater on the left is visible in the center of the next photo. The other planets show scars caused by rocks hitting from space. Many were large enough to have created worldwide destruction if they had crashed here. For example, in the outer solar system, the planet Uranus was once struck heavily by an object twice the size of Earth. This resulted in its axis being knocked at a right angle, instead of being upright like the other planets. As a result, one half of the planet faces towards the sun all the time, while its other half is forever dark and cold. Only a couple of years ago, Jupiter was struck by a comet that likely would have wiped out all human life had it hit the Earth. Noah's flood is the largest disaster discussed in the Bible, but Earth has experienced widespread destruction from space.
On Friday the 13th, April 2029, an asteroid large enough to fill the Rose Bowl, as though it were an egg cup, will fly so close to Earth that it will dip below the altitude of our communications satellites. We did not name this asteroid Bambi. Instead, we named it Apophis, after the Egyptian god of darkness and death. Neil deGrasse Tyson.
Earth's neighborhood. Each May, the Eta Aquariid meteor shower is visible in Australian skies. This happens as the Earth passes through the stream of ice and dust that trails behind Halley's Comet. But there is no need to wait for such an event. Patient sky watchers will see the flare of several meteors hitting our atmosphere every night. It is even possible to see the flash on the shadowed face of the Moon as one strikes there, adding to the many craters visible on its surface. Just under 40% of these fragments of rock originate from a single group of stony asteroids, known as Flora Ariadne after its two largest members. Asteroids come in families or clans which have a similar character. Over time, their numbers increase as they crash into each other and break up, while gravity now and then fuses some. Most have a common origin in a larger body. Family members are the broken remains of a few larger parent asteroids, so they have the same mix of elements. The Flora Ariadne clan members come from an original gigantic parent rock about 300 kilometers in size, but include a few rocks from other regions. The ages it takes for significant collisions, along with the weathering on the surface of asteroids from tiny impacts, show all these distant objects have endured through many long ages. There are around 900 asteroids larger than 1 kilometer in Earth's neighborhood. 1,200 that are mid-sized, and so on, with increasing numbers but getting smaller, until they are only dust-sized fragments. Each of the bigger bodies creates only a tiny risk to Earth. Not, however, zero risk. So we have had many fiery visitors over millions of years. Many meteors are no more than tiny rocks that won't reach the ground. Still, the Earth also has craters from much larger ones. The oldest craters are buried, and some are worn away by the natural forces of erosion and hardly visible. All of them can still be identified as an impact site. Usually, from the specific features of the rock layers they leave buried below. These include shatter cones that point directly towards the impact, and small glassy balls of rock, melted and thrown up by the force of the strike. Also tiny diamonds, formed by the intense pressures on fragments of carbon and rare elements, including iridium, which is uncommon on Earth, but often found in meteors. Lunar history and the Apollo missions. As Galileo observed, our Moon is covered with many layers of craters. Due to the lack of atmosphere, they are not worn down. Even small rocks can make deep, sharp-edged craters since they strike the lunar surface at speeds of 90,000 kilometers per hour. Newer impacts are well-defined, with clear edges. Around each circular crater are the debris from rocks, thrown up and melted by the crash. Viewed in infrared light, during the dark of the moon, the ring of each crater and its surroundings glow with heat. This is soaked up on days when these rocks are lit by sunlight. This fact provides an accurate measure of the age of the craters. Newer craters are taller and have cleaner and sharper rock surfaces. So, they absorb more heat from sunlight and can be labeled as recent. Also, some craters overlap others, showing that they definitely occurred later. That helps with dating, since larger craters are showered with a steady rain of minor impacts. Online geological maps of the moon provide a sense of its age and complexity. More evidence lies beneath the lunar surface. A 2012 gravity map of the moon was completed by the Grail mission. That shows it has a thin crust that is deeply excavated by impacts. It also has many older buried rings, from early impacts, that are now hidden by later eruptions of lava. When the Apollo missions explored the moon, they returned with many samples. In later decades, satellites have undertaken sensitive measurements of the moon's magnetic fields, revealing its structure. Also, several meteorites discovered here on Earth were blown into orbit from impacts on the moon. Similarly, small amounts of Earth's rocks have ended up on the moon when enormous collisions with our planet threw debris into space. By recording newly formed craters and the other techniques I've mentioned, and by directly dating the Apollo samples, we can calculate the age of the whole moon. Science has identified two periods of lunar impacts. The first period had frequent impacts from large objects. The solar system's early years were violent and unstable compared to the calm of the present. After the destruction caused by the first massive impacts ended, smaller strikes continued until the present. This long period included occasional temporary increases due to distant events in the asteroid belt, such as collisions breaking up larger bodies. These collisions between colossal asteroids scattered fragments across the solar system. Since that first wild period ended, the record of strikes on the moon and the Earth have been closely synchronized, and both records can be matched up. For example, when the moon had a period of increased impacts 290 million years ago, that is matched by a similar increase in the number of craters on Earth of the same age. As identified by the geology in which they occur, erosion and other methods. The solar system's largest crater is on the moon's unseen side, that always faces away from the Earth. It stretches across a quarter of its surface, down towards the lunar South Pole. Its vast size, at 2,500 kilometers wide and 13 kilometers deep, makes it unique in the solar system. It is also one of the oldest, covered with numerous smaller craters, both inside and intersecting its rim. The comet or asteroid that created this crater is estimated to have been around 170 kilometers across. The giant impact produced a plume of hot rock that speared right through the moon's center. It carried many volatile and radioactive chemical elements, from the moon's deep core to the near side facing the Earth, the upper and opposite side to the impact point. In time, that created darker melted volcanic regions, or seas on the Earth-facing side, that are missing from its hidden face. That has more craters, but less volcanism. So, when you see the moon rising over the horizon, with its dark seas, you are witnessing a world-shattering impact that occurred in deep time. Worst day ever, so far. Nature can recover from immense damage to ecosystems, given time. 66 million years ago, this resiliency was put fully to the test. A rocky asteroid, laced with metals, struck just about the worst possible place on Earth. The shallow coastal seas, off South America's Yucatan Peninsula, gave no protection from the impact. The asteroid hit the Earth at more than 240,000 kilometers per hour. The explosion released over 2 million times more energy than the most powerful atomic bomb. Just after the impact, deep granite bedrock flowed like a liquid. It rebounded into a central tower of fiery destruction, as tall as 10 kilometers, at the center of a deep, circular crater. The whole region was then covered by falling jumbled-up rocks and impact melt. In the following hours, ocean tsunami dumped vast amounts of sandy sediment into the hole in Earth's crust. Earth's history is forever marked by this impact, when a 10 to 15 kilometer-sized asteroid caused the Cretaceous Tertiary extinction. It wiped out many thriving ecosystems and species including the dinosaurs. Due to its effects, many other species became extinct, including larger mammals, pterosaurs, and most birds, lizards, insects, and plants. In the oceans, even creatures such as sharks died in great numbers, leaving layers of their teeth on the ocean floor. Vast as this event was, it is not the greatest or even second largest extinction. It was only the third largest of these events that Earth has suffered. Why is this significant for Christians? First, it shows that the rest of nature is consistently hostile to living things, and this flaw extends beyond our own world. Second, it illustrates how incomplete the Bible is. If we try to use it as our only source of universe-wide history, this great dying, and many other events, must have occurred after the origin of sin, yet they are not explained by any flood, no matter how complex. An explanation, such as a gap in Genesis, does not help, because they are not events from any good creation, but chaotic in every sense of that word. Scientists examined the original site of the impact crater in 2010. Samples showed that vast amounts of rock were shattered and vaporized at the site. The impactor was so large that when the asteroid penetrated the seabed, its upper half was still above the atmosphere. The collision force liquefied granite, causing it to explode kilometers outwards, into orbit around the globe and back into space within minutes from the wound in the crust. The clouds of pulverized rock it threw up were a primary cause of the extinction that followed. They blocked sunlight, halting plant growth across the planet for years, and created extreme climate change. The KT boundary clay, which is found across the world, was created by this cataclysm. Its effects spread across the entire planet. Antarctica, which was not yet over the pole, experienced a 65 to 70% loss of many plant, insect and animal species. That loss is shown by more than 6,000 fossils sampled from Antarctic islands. Pollen is a fine powder produced by many different types of trees, flowers, grasses, and weeds. Its grains are sturdy, so it is often retained in geological layers along with spores from plants like ferns. Even the simplest plants suffered greatly due to the impact. Especially in the Americas, closer to the impact site, while seawater temperatures were also affected. The impact waves spread around the world in a predictable path. These oversized tsunamis eroded the seabed as they passed and left deposits as far away as the east coast of New Zealand, and all around the Atlantic. The initial wave is estimated to have been over 4,000 meters in height. Modeling shows it took the first waves just an hour to expand past the Gulf of Mexico and into the North Atlantic. 4 hours later, it passed through the wide gap where today North and South America are joined, and into the Pacific. 1 day after impact, the waves had crossed most of the Pacific from the east and most of the Atlantic from the west, and entered the Indian Ocean from both sides at once. By the second day, gigantic tsunami waves had flooded most of the world's coasts, crossing and recrossing the globe. The impact also created earthquakes, larger than any in human history, with shaking and aftershocks for up to a month. The view from Tanis. At the Tanis archaeological site, a record of the impact event is preserved. This area was a long, narrow valley at the time of the extinction. A meandering river flowed down with many bends to an inland sea. It was a vibrant, green country with tall ferns and mature trees. Many fish were found in its large river, and marine reptiles, pterosaurs, turtles, and even small mammals climbed, landed on and burrowed in its banks. There were many dinosaurs in the surrounding forest. Just about all the major families from this era have been found. Wildflowers added color to the scenery. From the fish and flowers buried, it was late spring or early summer when the asteroid struck. The valley was over 3,000 kilometers from the impact. It was just as doomed as closer sites. All that remains of this landscape today is a thick, crumbly layer of rock. It is in what is today North Dakota, and the rock is crowded with beautifully preserved fossils. The first effect was a wave of heat that flashburned trees and animals near the coast. The impact threw material into space as far as the moon. Its return into the atmosphere then released so much heat that firestorms would ignite across the planet, and air temperatures briefly rise to oven-like heat. Later would come acid rain, a years-long winter, and, finally, more than 5 degrees of global warming after the sky cleared. Within minutes of the impact, earthquakes created a 10 to 12 meter surge of water at the site. This wall of destruction roared up the narrow valley from the sea, carrying a tangled wreckage of mud, fish, plants, tree trunks, and dinosaurs. The surge pushed this material and many of the broken trees and creatures against a sandbar. This was high up the river and today forms the base of the fossil bed. They were lined up with the direction of the surge against the usual river flow. The fiery sky continued to rain down glassy beads of molten bedrock, called tektites, across the planet, but many more landed on Tanis. These left tiny impact craters in this material where they landed. Today's site includes fossils of saltwater sharks and ammonites, washed in by the surge from the ocean and buried. Also, freshwater bottom feeders like sturgeon and 6-foot-long paddlefish. Many with tiny spheres still stuck in their gills from the vaporized rock falling from the sky. These spheres impacted with great force, penetrating the layers of debris. Some tiny spheres were preserved in tree resin from the surrounding forest. This solidified into amber that was buried with the other fossils. They were found together with a few fragments from the metallic asteroid itself. Clear proof of both the impact and the destruction that followed. After the earthquake surge buried the remains, the sky continued to rain ash and more rock from the comet. It created a layer that is rich in the key element iridium, a reliable signal of asteroid material. Any life that remained would have had to cope with the wildfires ignited by the burning fallout. The fertile river valley was transformed swiftly into a hellish wasteland. Worldwide a few birds survived, but all were ground-living or burrowers living off worms and insect life. They were the only ones to survive the impact and what followed. All living birds today are descended from these survivors. The many dinosaur fossils at the site prove that non-bird dinosaurs were still doing well until the day of the impact. However, dinosaurs are only one part of the story. The impact caused the death of entire, complex ecosystems on land and at sea. Only creatures living on the deep sea floor were unaffected in the oceans. The catastrophe caused a collapse of the entire ocean ecosystem and the extinction of many oceanic species worldwide, with flow-on effects lasting for 80,000 years.
A postscript to Armageddon. Walter Alvarez was one of the researchers who discovered evidence of the impact and first linked it to the extinction of the dinosaurs. He put the event into context this way. The sudden loss of 2/3 of the genera of plants and animals on Earth is a catastrophe almost incomprehensible to us. It truly marked the end of a world. And yet, the darkness eventually faded, the heat died down, and the acids were neutralized. Our nostalgia for the lost world of the Cretaceous is tempered when we realize that it was a world that held no place for us for large mammals. We are the beneficiaries of Armageddon.
A lost world. The photo is of the KT boundary layer, as visible in Long Canyon, Trinidad Lake State Park, Colorado. For the dinosaurs and so many others, the impact ended their existence. A few may have survived just as Gorgonopsids did after the end Triassic extinction. The idea of dinosaurs living on, protected in isolated refuges is disputed. Their fossil bones may simply be relocated from older layers, but it might be true. Could most of a world die without a few pockets of survivors? Sadly, the dinosaurs were fast-maturing giants needing much food. Earth's climate had changed forever and filtered out the species they depended on. So, any survivors were doomed, relics of a vanished age. The mammals and birds would spread to take advantage of the devastated world, but these species had a challenging start. The survivors' history continues at Corral Bluffs in present-day Colorado. It was September 10, 2016, Tyler Lyson, a paleontologist at the Denver Museum of Nature, was searching for fossils. Although the area had been searched by fossil collectors since the 1930s. As he recalled in an interview with the Washington Post, they were coming to the end of a collecting season with few discoveries. Tyler then remembered a technique he learned from South African paleontologists. Search for unusual-looking rocks instead of bones. His attention was drawn to a pale lump, a glob of rock looking like a squashed loaf of bread. The moment is fixed in his memory. I picked it up and cracked it with my rock hammer and broke it in two. And I could see the cross-section of a mammal skull staring back at me. It was just, I almost had tears in my eyes. Other researchers in the group looked for similar conglomerate rocks and quickly found two more skulls. Paleontologists might not find a single early mammal skull in a lifetime of searching, so it was a magnificent discovery. This was just the beginning of their discoveries and research. Altogether, his team found an astounding collection of fossils at Coral Bluffs. This included more than 1,000 vertebrate remains, mammal bones, turtle shells and crocodilian skulls. There were more than 6,000 petrified leaves and other plant parts and 37,000 grains of fossilized pollen, as well as seeds, leaves, roots, branches, complete sapling trees, and large stumps and logs. This deposit had been laid down over 1 million years and covered the period before, during, and after the impact. The remains were dated using volcanic ash and other indicators, providing a timeline of events. Before the asteroid struck, the Coral Bluffs region of Colorado was wooded with a tropical climate. The woodlands were home to Triceratops, armored ankylosaurs, Tyrannosaurus rex, and duck-billed dinosaurs. Until a gigantic chunk of rock and metal, striking near Mexico, punched a hole in the earth. The fossils Tyler discovered showed that mammals were horribly affected by this disaster. The largest survivor was only about the size of a rat. Bigger mammals had been completely wiped out. The diversity of all plant life had more than halved. From the fossils, it was possible to trace not only changes in plant species, but temperatures at the site, including the global winter, caused by the impact itself and the following spike of extreme warming. 100,000 years after impact, ferns were still the main type of plant life. The first post-extinction mammals were tiny omnivores, most living on insects. Gradually, over the next 100,000 years, the plants recovered, and palm trees returned. Mammals such as Loxolophus grew to the size of a small cat, and Carciopticus about as large as a small pig. There was a shift in species to more plant-eaters as plants grew taller and more diverse. It took until 300,000 years, after the impact, for mammals to recover, along with richer plant life. By then, animals had reached 22 kilograms in weight. At this time, full-sized trees also returned to the site, with pollen from walnut trees appearing in the fossil layers. It was not until 700,000 years, after the impact, that the capybara-sized Taenia labis and the wolf-sized Eoconodons appear in the fossil record. They were well above the average for mammals in the time of the dinosaurs. This was the beginning of their dominance in Earth's landscapes. Other cosmic impacts. Apart from the formation of the Moon, there have been many other impacts in Earth's history. About 800,000 years ago, there was an enormous one somewhere in Indochina. This may have been an airburst from a comet, since no crater has yet been found. It dropped materials 8,000 kilometers away in Australia, and as far as Antarctica. Around 12,000 years ago, a large comet of a similar type may have exploded close to the Earth's surface. That event likely contributed to the extinction of many large Pleistocene creatures. At the same time, human cultures in Europe and North America disappeared or were severely disrupted. This event has been confirmed by geological sampling in North America and elsewhere. In December 2018, a meteor only 10 meters across broke up above the ocean near Russia's Kamchatka Peninsula. It exploded with a force 10 times larger than the bomb that annihilated the city of Hiroshima. Fortunately, it broke up in a remote location. While very recently, a 35-meter rocky asteroid had a near miss in July of 2023. It was only discovered a few days after safely passing the planet. Had it struck a major city, it could have been deadly. Impacts this size or near misses, like the Chelyabinsk meteor, occur every couple of decades. Other planetary surfaces, throughout the solar system, share the same pattern as the Moon. That is, an early major bombardment by gigantic rocks, followed by regular hits by smaller bodies over a long period. That has left widespread scars across the planets. Consider Mars, which has more than 600,000 impact craters of 1 kilometer or larger. Mercury also has prominent features such as the Caloris Impact Basin, which is 1,500 kilometers across. For scale, Earth's largest known crater was only 280 kilometers across when formed. The asteroid that caused our largest crater struck 2 billion years ago. It was twice as large as the one that killed the dinosaurs. Yet its impact was a pinprick compared to strikes on other planets. As described, Mars shows signs of being hit by several rocks exceeding 100 kilometers in size in its deep past. Can humans expand from a purely Earth-focused future? Like the dinosaurs, we are at risk. To guard against such threats, spreading earthly life to other planets is one option. That would protect civilization against extinction events. Mars would be a harsh, but viable place to live as an initial world. Buildings would need to be partly underground, or within domed cities. Essentials like sufficient air and water would be a struggle. It could be many decades before Martian colonies were well established. While full independence from Earth would take centuries. There will, I hope, be many Christians living on the Moon and on Mars someday. Living their whole lives beyond our world. Luckily for us Earthlings, monster-sized asteroids are uncommon, but a peppering of small meteorites continues to rain down on us. An expedition to the Atacama Desert in Chile recovered many meteorites. They had rested on the surface since colliding. Some for a few decades, others up to 2 million years. Their ages showed steady impacts over time, with only minor variations in the rock's makeup. Australia has some of the earliest dated rocks in existence. These are found in the cratons of Western Australia. They preserve the remains of impacts so old that they are only visible in deeply buried impact structures. One of these is the Yallali impact feature, 200 kilometers north of Perth. We also have the currently oldest known crater in the world, at Yarrabubba, which is east of the inland town of Meekatharra. That was once a large crater but is now detectable only in shatter cones and other rock traces and in magnetic maps of the area. Earth has essential geological systems, which support life by recycling older rocks and bringing up new material. The evidence from the rocks of Western Australia and South Africa shows that this flexibility owes a lot to the impacts from space that Earth experienced early in its history. Like a volcano's slopes where the soil is fertile, Earth is rich in life because it is unstable and dangerous. The surfaces of large and small asteroids are cratered. So are the rocky and ice-covered moons of the outer gas planets. Since all bodies in the solar system share a history of being struck violently by rocks from space, finding craters everywhere is natural. Geology and deep time is not just about the one planet we live on. According to Craig O'Neill, we tend to think of the Earth as an isolated system, where only internal processes matter. Increasingly, though, we're seeing the effect of solar system dynamics on how the Earth behaves and how it came to be. How can these long-term impacts and the history of the solar system fit into a young creation? We'd have to explain the levels of erosion on craters right across the solar system. There are so many other physical features that require an explanation. For example, how the rest of the universe was putting out millions of extra cosmic rays per hour compared to today. At the same time, the solar wind from the sun needs to increase to age surface rocks. In addition, an explanation is needed for the consistent rates of radioactive decay of the uranium, thorium, rhenium, samarium, rubidium and potassium-40 in samples taken from the Moon and Mars and beyond the solar system. Since none of these things were anywhere near either the Earth or any flood. It's really a lot of work to explain away the dates coming from places so far from our planet. Unfortunately, things are not likely to get easier to explain as we return to visiting the Moon and travel deeper into space. Defending the accuracy of the Bible is wonderful, but being convincing in our explanations is equally vital. We should shake off the limitations of young Earth theories. They cannot provide any explanation that works, no matter how complex they become. Particles from deep space. Except for the Moon and a few stray planets, the night sky appears empty and peaceful to human sight, but it is far from tranquil. If you could view it in every frequency of light, it would look like an immense fireworks display. There would be constant blossoms of light and background glow, all through the electromagnetic spectrum, from radio to gamma rays. Apart from light, small matter particles rain down all the time on the Earth. You are being hit by several hundred secondary particles from cosmic rays as you read this paragraph. The rays are actually high-energy particles arriving from distant galaxies. The most energetic of them are produced by enormous black holes, devouring stars in the centers of neighboring galaxies. When one of them hits an air molecule, secondary particles spark away from the impact in showers. Equally significant is where the rest of these particles come from. The majority were once just normal space debris, including widely scattered atoms from nebulas or tiny remains from broken-up planets or asteroids. However, when a nearby star exploded, they were hit by its shock wave. Extraordinary amounts of energy are released when a star blows up, releasing a supernova. Struck by this wave of energy, the tiny harmless particles were transformed into bullets fired across space. The highest energy cosmic rays, generated by black holes, are even faster than bullets. They are more like the particles produced by the most powerful atomic accelerators. Stars do not change much across geological time. Instead, they move through their life in stellar time, recorded by the expansion of the universe and the spin of galaxies. Still, the larger they are, the faster their time comes to an end, and they shatter. That seed space with their glowing remains. Striking Earth from every direction, all of the time, cosmic rays are the most dangerous effect of these explosions. Gigantic rocks hitting the Earth show us the long-term dangers of our universe. These tiny speeding particles are also a risk. They affect the long-term development of species. Along with natural radioactivity, they damage cells' instructions. Mutations from repairing these breaks are one of the sources of variation in species. That is the pool that adaptation draws on for new body parts, behaviors, and abilities. The main source of mutations are chemicals and copying errors when cells divide. However, damage from interstellar particles may also be quite high. Solar activity and the Earth's own magnetic shielding are also part of this situation. For both affect how many of the really dangerous particles make it to the ground. Wherever we are on Earth, we are all being struck. Unless you're deep underground or living under thick lead roofing. Compared to boulders and other heavy objects, our bodies are not dense. Rocks and especially crystals collect a lot more radiation from cosmic rays. As a result, their structure alters. Depending on the nature of the exposed rock, some of its crystals build up a trapped electrical charge within tiny flaws. The remaining charge is one way of figuring out how old a sample or artifact is. It indicates the amount of time since a fragment of rock was last exposed to sunlight, or to the cosmic ray showers that fall constantly. Why do astronauts see mysterious brilliant flashes when they enter deep space, even with their eyes closed? Cosmic rays make many other particles when they collide with solids. Our Sun releases these high-energy particles, which flood into space constantly. They are likely to hit something as they pass through the fluid inside the eye. A strike causes a storm of secondary decay particles, which includes light. Dangerous particles shoot right through the rest of the body, sometimes hitting cells. If the cosmic ray and radiation exposure is severe enough, it may be fatal. This makes lengthy journeys, like those to the Moon or Mars, risky. Cancer or even death from radiation sickness are a possibility if a major solar flare floods out from the Sun in the traveler's direction. Severe solar storms, generated by our Sun, can disrupt the protective magnetic field of the Earth that keeps us safe. Plants retain a record of the damage when this occurs. These high radiation episodes cause up to 20 times the typical amount of the isotope carbon-14 to be formed. That carbon is then stored within the plant cells and their buried remains. Since it has 2 more neutrons in its nucleus than regular carbon atoms, it is somewhat radioactive. The outcome is similar in ice cores which are also altered. We can use these changes, along with volcanic eruptions and other processes, to date extreme events on the Sun during human history and beyond into deep time. Widespread effects of the fall. These features of our universe have no rational explanation in flood theories unless we imagine a lot of other strange and non-biblical things that are happening too. Planets and moons throughout the solar system and around other stars show the effects of chaos and the fall. While flood-based theories cannot provide any explanation beyond our own world, Earth itself has experienced impacts and icy glaciations, sometimes reaching right to the equator, and vast eruptions. The composition of the atmosphere has also changed over time. The planet Mars has a layer cake of ice and dust under its present polar caps, charting millions of years of climatic change. With the exception of impacts, these eras of fire and ice occur in geological time, not during a couple of years of upheaval.